Welcome everyone. I am Swati from the Venkateshwara College of Engineering, first year BE from the Department of CSE AI. Now, I am here to explain about Introduction to Integral Calculus. Now, let us start the session. The topics to be covered in this session are Introduction of Integral Calculus, the definite integral, the indefinite integral, fundamental theorem of calculus, techniques of integration, applications of integral calculus, Riemann sum, improper integrals, numerical integration, and the end, the conclusion. Now, let us start the introduction of integral calculus. Integral calculus is a branch of mathematics that deals finding the area under curves. It is a powerful tool used to solve problems involving accumulation, such as finding total distance traveled or total amount of substance. Integral calculus is closely related to differential calculus as they are both fundamental components of calculus. Now, let us see about the def- definite integrals. The definite integral represents the accumulation of a function over specific interval. It is denoted by integral symbol and has a upper and lower limit of integration. The result of the definite integral is a single value representing the net accumulation of the function over the given interval. Next, the indefinite integral. The indefinite integral represents the antiderivative of a function. It is denoted by integral symbol followed by the function with no limits of integration. The result of the indefinite integral is a family of functions where each member differs by a constant. Now, let us know about the fundamental theorem of calculus. The fundamental theorem of calculus establishes a connection between differentiation and integration. Part 1 that if a function is continuous on a closed interval, then its antiderivative exists. Part 2 states that the definite integral of a function can be evaluated by finding any antiderivative and subtracting its values at the limits of integration. Now, let us see about the techniques of integration. There are several techniques for evaluating integrals, including substitution, integration by parts, and partial functions. Substitution involves replacing variables to simplify the integrand. The integration by parts is used to integrate the product of two functions. Now let us see the applications of integral calculus. Integral calculus used in various fields such as physics, engineering, economics, and biology. It can be used to solve problems involving velocity, acceleration, work, and growth rates. In economic, integral calculus is used to analyze consumer and producer circles. Now let us see about the Riemann sum. The Riemann sum is a method for approximating the area under a curve. It involves dividing the area into smaller rectangles and summing their individual areas. As the number of rectangles increases, the Riemann sum approaches the exact value of the integral. Now let us see the improper integrals. Improper integrals involves evaluating with infinite limits or integrands that are undefined at certain points. They can be classified as type 1 or type 2 depending on the behavior of the function. To evaluate improper integrals, limits are taken as the endpoints approaches infinity or undefined points. Now let us see about the numerical integration. Numerical integration methods are used when it is not possible to evaluate an integral analytically. Some common numerical integration techniques include the trapezoidal rule and Simpson's rule. That is Simpson's rule. These methods approximate the area under the curve by dividing it into smaller segments and applying specific formulas. Now we reach the last part of the session, that is conclusion. Integer calculus is a powerful mathematical tool used to find the area under curves and solve problems involving accumulation. It is closely related to differential calculus and is essential in various fields